Hello class. In this video we're going to be talking about the third application of the derivative as it relates to the elasticity of demand in microeconomics. The elasticity of demand in microeconomics involves a derivative, and so we're using it as one of the applications of the derivative in your business calculus class. So I do believe this is the 10th and final video of our series for the videos leading up to exam 1. So after this video, you can work the 8th and the 9th problems, and last 2 problems of the module 1 applications homework in WebAssign. So I am working we're going to be doing example 1 in of the first elasticity demand example, and it's on page 30 of the short packet that I handed out at the beginning of the semester, and I believe it's on page 31 if you have the large packet purchased from the bookstore. So on the wall here at the top of the page, okay, you're given the demand equation for this example, and the demand equation is x equals minus 3/2 p plus 15. P is the independent variable in this equation. X is the dependent variable. So the role of x has changed. Traditionally, x is the dependent variable on the right-hand side, but in this case, it's the independent variable. P is the price of a product, and X is how much that product is purchased by consumers at that price. And in this example, X is measured in units of 100. Okay? So this is really just this demand equation is the equation of a straight line. And so I have graphed the demand equation over here, and we just graph it in the first quadrant of the coordinate plane, because price can only be positive, it can't be negative. And to illustrate the demand equation, at a price of $4, we put in 4 for P, right? The quantity demanded, the quantity sold to consumers at a price of $4. When you plug in for P into the equation, you get X is equal to 9. And this is actually 900 units of the good, because X is in hundreds. Well, if we replace X with f of P, okay, we now have the demand function for this good. And so we have, and it's a linear function, right, because it's the equation of a straight line. So we have f of P is equal to minus 3/2 P plus 15. The elasticity function, which measures the elasticity of demand at a given price, is given in your notes in the rectangle. E of P is equal to the negative of P times f prime of P, right? That's the derivative of f of P divided by f of P. Now, I notice a lot of times students will lose sight of the negative sign out front, so I moved it into the numerator. We can do that. This is the same as minus P times f prime of P over f of P. So we know what f of P is. We're going to need f prime of P in finding the elasticity function. Well, the derivative f of P using the rules of differentiation, derivative of minus 3/2 P is minus 3/2, and the derivative of a constant is 0. Now you could have also got that just by noting, since this is an equation of a straight line, the slope of the line is minus 3/2. So you could have noted it that way as well. So the right, E of P is function notation. So E is for elasticity and P is for price. So E is the name of our elasticity function, and P is the independent variable. So we have to plug in for f prime of P and f of P and simplify to get the elasticity function in part A. So when we do that, we have in the numerator minus P times minus 3/2, And in the denominator, we have minus 3/2 p plus 15. Well, in the numerator, when you simplify the numerator, negative times a negative, you know, is positive, so the minus signs go away, and we're just left with p times 3/2, which is the same as 3/2 times p in the numerator. And the denominator, we can switch the denominator and write it as minus, or we can write it as 15 minus 3/2 p. Now you're instructed in part A, right, in finding E of p, to simplify any complex fractions. And a complex fraction is a fraction that contains fractions. So we have a fraction in the numerator, we have a fraction in the denominator. So we got to clear those fractions in the numerator and denominator. And to do that, we're going to multiply top and bottom of this big fraction by 2. So we have E of p multiply the top by 2, multiply the bottom by 2. And you have to multiply both those terms in the denominator by 2, so you got to put 15 minus 3/2 in parentheses. And then you use the distributive property in carrying out that multiplication in the denominator. Well, 2 times 3/2 is 3, and so the numerator just simplifies to 3p. And the denominator, right, 2 times 15 is 30. And 2 times 3/2 again is 3. And so the denominator simplifies to 30 minus 3p. So that is the elasticity function E of p. Right? E of p is equal to 3p divided by 30 minus 3p. In part B, you're asked, is the demand elastic, unitary, or inelastic when the price is $8? So to find the elasticity at a price of $8, we just plug in 8 for P in part A, the elasticity function. So in part B, we just put in 8 for P down here on the right-hand side. And when we do that, we have E of 8 is equal to 3 times 8 over 30 minus 3 times 8. And so in the numerator, that's equal to 24. In the denominator, that's equal to 6. And 24 divided by 6 is equal to 4. Now in the rectangle at the top of the page, you're told that demand is elastic if this number on the number, our answer, is greater than 1. Demand is unitary if this number is equal to 1. And demand is inelastic if this number is less than 1. Well, this number is greater than 1. So at a price of $8, demand is elastic. In part C, you're asked for what price P is the demand unitary. Okay? Well, demand is unitary, right, when the value of this right-hand side is equal to 1. So E of P, our elasticity function, is equal to 3P over 30 minus 3P. So we got to find the value of P that makes the right-hand side equal to 1. So I'm going to replace E of P on the left with 1. And now it's just algebra. We got to find the value of p that makes the right-hand side equal to 1. And so to clear the fraction on the right-hand side, we multiply both sides by 30 minus 3p. And we have 30 minus 3p is equal to 3p. And now we add 3p to both sides, and we get 30 is equal to 6p. And then when we divide both sides by 6, we get 5 is equal to p, or p is equal to 5. 5 what? $5. So a price of $5 per unit for this product, okay, gives us an elasticity of demand that is equal to 1. The elasticity of demand will be unitary at a price of $5. So that's example 1 in your note packet. Example 2 is similar. The demand equation is just changed, but the process is the same. So you're given the demand function in example 2. Is f of p equal to minus 3/4 p plus 40. So in calculating the elasticity function, we need the derivative, f prime of p, and f prime of p is equal to minus 3/4, right? Derivative minus 3/4 p is minus 3/4, derivative constant is 0. And you could have also got that by just realizing this is linear. This is a linear function. And so the graph of a linear function is a straight line. And the graph of the straight line, the slope of the straight line would be minus 3/4. So in part A, you have to calculate the elasticity function, E of P, which I write as minus P times f prime of p over f of p. I brought the minus sign that was out in front of the fraction into the numerator. I can do that. And now when I substitute, I have minus p times minus 3/4 over minus 3/4 p plus 40. And now we simplify. In the numerator, negative times the negative is positive, so the minus signs go away. And then we have p times 3/4, which is the same as 3/4 times p. And in the denominator, I can write that as 40 minus 3/4 p. Now we got to clear the complex fractions, right? This is the, we got to clear the simplify the complex fraction. We have a fraction in the numerator, fraction in the denominator. So to clear those two fractions, we're going to multiply top and bottom by 4. And so we have E of P is equal to 4 times 3/4 P over 4 times 40 minus 3/4 p. Right, all I did was multiply top and bottom by 4. And you got to put the 40 minus 3/4 p in parentheses, because you got to multiply both those terms by 4. So we'll distribute the 4 in the denominator. In the numerator, 4 times 3/4 is 3. And in the denominator, 4 times 40 is 160. And 4 times minus 3/4 p is minus 3p. So E of P is equal to 3p over 160 minus 3p. In B, you're asked, is the demand elastic, unitary, or inelastic when the price P is equal to $10? Well, to determine that, we got to put in 10 for P in the elasticity function. So we have E of 10 is equal to 3 times 10 over 160 minus 3 times 10. Well, the numerator is equal to 30. The denominator is equal to 130. And 30 over 130 simplifies to 3/13. And you can recognize that's a proper fraction, right? Proper fractions are between 0 and 1. So this fraction is less than 1. And you can also use your calculator to get write out the decimal value, which is 0.23. And you know the decimal 0.23 is less than 1. And so from the rectangle up above, if the elasticity is less than 1, which it is in this case, then demand is inelastic at that price. So at a price of $10, demand is inelastic. Elasticity is less than 1 at a price of $10, so demand is inelastic at a price of $10. In part C, you're asked for what P is the demand unitary. So again, we have to substitute, we got to find the value of P that makes what's in the box here equal to 1. Right? So in part C, our elasticity function, E of P, is equal to 3P over 160 minus 3P. And so we got to find a value of P that makes the right-hand side equal to 1. So we replace E of P with 1, and we have E of P is equal to 3P over 160 minus 3P. And now, to clear this fraction on the right-hand side, I multiply both sides by the denominator here, 160 minus 3P. And I have 160 minus 3P is equal to 3P. And now in solving for P, we add 3P to both sides, and we have 160 is equal to 6P. And now when I divide both sides by 6 and switch both sides, I get P is equal to 160 divided by 6. And to the nearest penny, right, we round to the second decimal place, and 160 divided by 6 to the second decimal place is $26.67. So at a price of $26.67, demand is unitary. Okay? The elasticity of demand will equal 1. And we're done. Example 3 is similar to example 1 and example 2. So I will post my solution to example 3 on Moodle. And it's just more of the same thing. Okay? So that wraps up this video series. You have everything to complete the web assignment homework leading up to exam 1, which is next week. Okay? Thank you.